This video will boldly cover all topics on Laplace inverse transform, alright, but not covered by me, but rather than a summary of what are the types, and then I'll just link you to the things that you really need for you to become a good Laplace inverse transform person. Alright, so therefore, if you want to learn anything about cover-up rule, if you don't know what the hell is this, I suggest that you click this link. It's very useful. Next, partial fraction. If you don't know anything about partial fraction, click this link. If you don't know anything about inverse Laplace using complete the square, click this link. Right, these are the first three types. Alright. Okay, I assume that you have already clicked something if you don't know anything. If you know everything, then coming up, long division method. Maybe not, this one first. If you happen that you don't know how to solve this type of questions using the cover-up rule and then some partial fraction method, I would just recommend that you click this link. If you don't know anything about long division method, I will recommend you click this link, which is this type of method. How do you solve? Alright. And if you still stay on and you feel that you are very highly confident, then I shall discuss with you what are the things that is required of you. Then if you feel that you really need to know the rest of the link, then you'll just click back the few minutes ago and click the link that you really need to know. So there are about 5 types of Laplace inverse transform questions. The first one is this type: 1 over s plus 2, s plus 1, s plus 3, s plus a, so on and so forth. Hike. Or otherwise you have something like a s over here. Alright? When you see this sort of thing, you should go and try out cover-up rule. Alright? These are all very nice. S plus 1, you know, and s. Alright? Cover-up rule should be fine. Alright? And therefore, what about this term? If you have this type, s squared plus s plus 1, this, and it cannot be rewritten as this form, because sometimes this can be rewritten. For example, s plus 2 and s plus 1, you can become s squared plus 2s plus 1 plus 2, sorry. Is it? Or 3s. Yeah. So this form can be rewritten into this form. Okay? But this is something that I want you to know also. Be very careful on how whether can this thing be re-represented by some sort of s plus something and s plus something. Alright? And therefore, if it's impossible, then you have another method to solve using cover-up rule first, because you have something that is pretty nice like s plus 2, and then solve using the partial fraction method. So therefore, just a quick summary is that if you were to write in terms of partial fraction for this case, this form a s plus 2 and this, right, I will assume that you already find this very familiar. If you don't know, then please click that link. Okay, please click that link. Alright, if I were to solve using cover-up rule, I will have some values of a, correct? For example, if I were to use cover-up rule, the value of a should be I think 1/3, I think. Anyway, so if I were to do that, then I can use the normal partial fraction method to just make the denominator all the same. So therefore I have 1/3 s squared plus s plus 1 plus b, and then s plus 2, and then all of this over here, right? So now solving for b is pretty much simple, because you don't need to do simultaneous equation due to a. Alright, so this is something kind of efficient, right? Because if you were to do only partial fraction, things can be more hairier and troublesome if you have more terms. For example, if I were to tell you that you have something like that, s plus 3, s plus 4, right? You can't be doing this long chunk of stuff, right? You're gonna kill yourself. So therefore, use cover-up rule to solve for all these nice numbers, and then in the end use the partial fraction O method to solve for this dude over here. and it should be fine, right? Now, the third thing is, if you have this form, alright, the only thing I want to convey to you on this form is that happen that I rewrite this thing as partial fraction again, okay? And you may be tempted to use the cover up rule, and definitely yes, you should do. But however, if you use cover up rule to solve for s plus 1, you'll get some value of a, right? I don't know what's the value, but some value a, alright? So I would write it as a. I don't want to know. Anyway, so if you get some value of a already, and then when you solve for s plus 2, right? When you cover up s plus 2 the whole term, right? So for example, if I cover up this term, right, I will have 1 over minus 2 plus 1, I will have minus 1. So this minus 1 is for C, alright, the highest order, alright? So in other words, when you do cover up rule, for example, what I've just done, when I cover up s plus 2, I have minus 1. This minus 1 is for the highest order partial fraction, alright, which is square. Alright, if it's cube, this is for the cube itself. Right, if this is cube, right, then this should be for the cube. If this is 4, then this should be for the 4. Then the rest of the little small one, like s plus 2 square, s plus 2 cube, you're gonna solve using the normal partial fraction method, like solving for the denominator and such, as we have discussed on this parameter. Alright, so these are the 3 things, yet we haven't finished yet. So as you can see, all this, the first 3 that I've just talked about are all more than one function, right? This is one function, this is one function, this is another one function. Alright, same as this one. These are multiple, like 3 functions together with it. Alright. Now, then there is the fourth case, the long division case. If you have something like s square, the order, meaning this is square and this is square, they are the same order, you can use the long division method. Alright, and I assume that you know what it is already, so this is why I'm not going to go through. But the key thing is that if you have s square or cube or 4, something that is greater than this denominator one, you should use the long division method. So keep this in mind, that if you see some question, take a look, is this the same order as this or higher order? If it's yes, then use the long division method straight away. Alright, provided that it's only one term. Okay, I forgot to say, provided it's only one term. So I repeat again, provided it's only one term, one function, one blah 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 blah. Anyway, so you're just giving one function. As you can see, previously we have all 2 functions. Alright, these are all 2 functions. If I were to just zoom out a little bit, it's all 2 functions. Then suddenly here is one function. Right? If it's one function and if the order is the same as the bottom one or even higher, then you're going to use the long division method. That's the key concept I want to convey to you. Please remember this. Alright, if it's denominator one function, order higher than the denominator or equals to, then you use the long division method. Now, what if I have one function yet it is lesser than the normal, the denominator order? This is s to the power of 1, which is smaller than s squared. How do you solve this dude over here? Alright, this is why I'm here to share with you the next and the last thing that I don't see in most Laplace YouTube websites. So I'm going to share with you now on these things. Right? The first thing first I do normally for this type of question is that I write the same numerator as the same denominator. If I were to write that, s squared plus 2s plus 3. Okay? So a little while I thought that I have confused myself. But anyway, if it's something that is smaller degree, small order, meaning s1, smaller than the x2 over here, the numerator is smaller than the denominator, what we can do is simply to just do completing the square method. Alright, if you do completing the square method, what we have is s plus 1 square plus 2. Okay, so how do you get that? Alright, if I do completing the square method, I assume that you know, but if you don't know, I'll just I assume you know. Alright, I'll just share with you something that is pretty different. I thought that it may be fairly useful also. Alright, so we have s squared over here, right? Just write it as s and s over here. And what makes it 2s? What are the same as and as? What should be this 2as such that it becomes 2s? as, so therefore a is equals to 1, right? So my purpose here is I have this s squared over here, I write it as ss, and then I write this as 2s. So what is the coefficient? Right, coefficient must be the same, alright? Must be the same coefficient that makes as plus as to 2s. So in other words, 2as is equals to 2s in this case. What is a? And therefore we know that a is equals to 1. Alright, so as, so we know that 1s lah, okay? 1s, 1s, 2s, right? So 1 times 1 is equals to 1, and this 1 will minus away this dude over here. Right, so first I split this up into s and s, and then I put it over here and I find what is the same coefficient here. I multiply them together and then I minus it away with, I minus it over here. Alright, I take this minus away this value. But I still highly recommend you go and use your completing the square method. Okay, therefore it will be easier. Right, if you happen that you forgot, at least this is something like a concept for you to check it out. Alright, so therefore we have something like that. Alright, after using completing the square. And I would assume that you already know how to inverse Laplace. So as you can see, completing the square, somewhat this is our trend is like a s plus 2 type of thing. Definitely this is s plus a sort of stuff. So you're gonna rearrange, right? You're gonna rearrange. You know that objective. Next thing you need to know is to know how to set your objective. What is this? You need to set in terms of s plus 1. So how? So how do you know that this? How to make this s plus 1? You just rewrite as s plus 1, s plus 1 square plus 2. Alright, so what makes this equation the same as this? Alright, you just simply plus 1, right? Plus 1, and then you have s plus 2 with the same denominator. Alright, so we have this, we know that this trend will be something like this, right? Maybe I should copy the picture, hold on. Yeah, as you can see, in terms of the s plus a, we have set the s plus 1 as the same. Alright, now what we need to do is that we know that this is one number only, and therefore it's something like that, right? And therefore what we can do is to check it out, this thing. What is this? This is 2, right? Which is square root 2. So if b squared is equals to 2, then b is equals to square root 2. So we want this top of this to be square root 2. So how do we do it? We can just simply write as square root 2 over here and just multiply with a coefficient of 1 over square root 2, and that's it. We have something that is pretty cool. And then let me zoom things up, at least you can see. So therefore this thing can be rearranged, as e minus t cosine 2t, right, plus this term over here, right? So what is this term over here? It's just simply 1 over square root 2 and then e minus t sine 2t. Alright, same thing. Where the convergence, it's minus a, and that's it. So it's somewhat given to you, so you don't need to do anything about it. Alright, so the key thing take away home of this type of questions, especially this two type of question, is to know how to set the objective, right? How to rearrange the coefficients, and how to know that s plus 1 plus 1 is equals to s plus 2 type of thing. You know, because for example, s plus 2 can be equals to s plus 1 plus 1. So you need to know all this. How do you set this thing? So you need to know your objective first. You need to know initially what is your equation first. What do you want? Or what do you want for your objective in terms of your final equation? This is the very key thing that you need to practice more. Alright? So what I can suggest that if you want to practice, just do some just also create some questions. For example, s plus 100, and then you can just write things in terms of s squared plus 2s plus 3, and then solve for this. You can always use calculator or things like that to check your answer. So I'll end this thing just to let you know, yeah, these are all the five general stuffs that is always tested in exams, and I hope that this is fairly useful. I didn't confuse you or anything. If you feel that I waste your time, I'm very sorry about it. So see you soon. Goodbye.